Day 338 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 264, ugly number 2. The difficulty level is medium, but you already know we're going to keep the solution as simple and easy to understand as possible, y'all. But before we get started, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. An ugly number is a positive integer whose prime factors are limited to 2, 3, and 5. Given an integer n, return the nth ugly number. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just so we can make sure that we are doing this problem correctly. So in example 1, we have n equals 10. The output is 12. Explanation is an array of integers the array of integers doesn't really matter, but I'll tell you why later. But it's 1, 2, 3, 4, 5, 6, 8, 9, 10, and 12 is a sequence of the first 10 ugly numbers. So the array of integers doesn't really matter right now because we're not returning the array of integers. We're just returning the output, which is in this case 12. So it says what they want us to do is they want us to find so n equals 10. That means they want us to find the 10th ugly number, right? So in this case, the 10th ugly number is 12, right? And all of these preceding ugly numbers are just the ugly numbers that come before 12, and they give us an example of what those numbers are. So as you can see, the first ugly number is always going to be 1 because even though we're looking for prime factors, numbers whose prime factors are limited to 2, 3, and 5, 1 has no prime factors at all, which means it doesn't violate the rule. So we're always going to start with 1. Then as you can see, 2 times 1, that'll give us 2, so that works. Then 1 times 3, that'll give us 3, so that works. Prime factor 3. Then 2 times 2 will give us 4, right? So that fits the rule. Remember, we're working with numbers 2, 3, and 5. 2 times 2, that'll give us 4. Boom. Then 5, we could do 1 times 5, and that'll give us 5. Then 6, we could do 2 times 3. 2 times 3, that'll give us 6. Or we could look up here, 2 times 3, that'll give us 6. Then we do 2 times 4, that'll give us 8. Then we do 3 times 3, that'll give us 9. Then we could do 2 times 5, that'll give us 10. Then we could do 3 times 4 to get 12. Right? So that's how we got all of these numbers. And as you can see, except for 1, because 1 doesn't have any prime factors, all of these numbers have at least one factor of 2, 3, and 5, right? All of these numbers, you need at least a 2, a 3, or a 5, and you can multiply them together and you could get any number in this array. But we're not, like I said earlier, we're not returning this whole array. We're just returning the 10th number in this array because n equals 10. And in that case, the 10th number is 12. As you can see, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers in this array. We just want the 10th number because because n equals 10, so we just return 12. Boom, and that's how we got 12, because we want the nth ugly number, and n is 10. So let's go ahead and take a look at example 2. It's more of just an example of when we're dealing with ones, but like I said before, 1 has no prime factor, so it doesn't violate the rule. We want all of the numbers whose prime factors are limited to 2, 3, and 5. But since 1 doesn't have any prime factors at all, we can include that as well. And all of the other prime factors, as you can see, are multiples of either 2, 3, or 5. Boom. So then example 2, we have n equals 1. The output is 1. Explanation says 1 has no prime factors. Therefore, all of its prime factors are 2, 3, and 5. Boom. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Now, solution is not that difficult at all, as you already know. We're going to be using some dynamic programming today, so get excited about that. Now let's get into it. Now, the first thing we need to do is, excuse me, y'all. First thing we need to do is we need to create our dynamic programming array, which will store the first n ugly numbers. So in order to do that, we can say var, we could just call it dp, we could set that equal to an array. Open up the parentheses, we're going to say repeating colon 0 comma count up to n. So what this is going to do is just going to create like a default array for us. All of the numbers to start will be 0, but we'll mutate those as we write our code, or our code will mutate those as we go further in. But it's going to be as many zeros in that array up until n. So just to give you a visual example, what it's doing is say we have 10, say n equals 10. It'll just create a default array for us of 10 zeros, and then as we go further along in our code, those zeros may change, but right now we just have a default value of an array with 0. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all this is doing, and it's whatever n is. So if n was 8, then we just get rid of these two and it look like this. You know what I'm saying? So that's all that's doing, but it's just a default array. As we continue down our coding, it'll change. So the first ugly number is 1, always by definition, because like I said before, it has no prime factors. So we could just set the first 0 in the array to 1. So we could say dp square bracket 0. We could just set that equal to 1 to start, because we know it's always going to be 1. Now we need pointers to track multiples of 2, 3, and 5. So in order to do that, we could just declare 3 pointers. We could declare a variable. We could call it pointer 1. We could set that equal to 0. Then we can declare another variable called pointer 2. We could set that equal to 0. Then we can declare another variable called pointer 3. And we can set that equal to 0, just like that. Now we need to generate the ugly numbers from index 1 all the way up to n minus 1. Why are we starting from 1? Because we already, from index 1, we already know index 0 is going to be 1, so we can start from index 1. Boom, so we're going to say for I n 1 dot dot less than sign up to n. So for 1 up to n, we're going to open up our brackets. Boom. Now we need to compute the next candidates by multiplying the values of each number. So we come right here, we can declare a variable called 2 multiple, and we can set that equal to the dp array. So dp square bracket pointer 1 times 2. Then we could declare another one for 3 multiple. So 3 multiple, we set that equal to, we could set that equal to dp square bracket pointer 2, but we're going to multiply it. So multiply it by 3. Then we could declare another one, and this one will be 5 multiple. So we could say var 5 multiple. We could set that equal to dp square bracket pointer 3, and we could multiply that by 5. Now we need to choose the smallest of the 3 candidates to keep the sequence sorted. So to do that, we just say dp square bracket I. We're going to set that equal to min, which is going to get us the smallest one, and we're going to say 2 multiple, then we're going to say comma, then we're going to say min again. We're going to open up the parentheses, and we're going to say 3 multiple, comma, 5 multiple. And that's going to give us this will give us the minimum of the 3 and the 5 multiple. And then once we find out, like PEMDAS, it's in parentheses. So once we find out the the minimum of the 3 multiple and the 5 multiple, we'll take that minimum and then we'll compare that with the 2 multiple and whatever this multiple is. Boom. Now we need to increment the pointers that contributed to the current minimum, and this ensures that we don't reuse the same multiple again. So we could come right here, we could say if dp square bracket I equal sign 2 multiple, then we're going to open up the brackets and we're going to say pointer 1 plus equals 1. So we're going to increment that. Then we're going to do the same thing for the 3 multiple. So we're going to say if dp square bracket I equals 3 multiple, we're going to open up the brackets and we're going to say pointer 2 plus equals 1. Then we're going to do the same thing for the 5 multiple. So we're going to come right here and we're going to say if dp square bracket I equals 5 multiple, we're going to open up the brackets and we're going to say pointer 3 plus equals 1. Now we're not done yet because we still need to return the nth ugly number on a zero-based index. So we just come right here and we could say return dp square bracket n minus 1, just like that. And that should be all she wrote, y'all. Let's go ahead and give it a run. Make sure it runs properly. And it's accepted, y'all. So let's go ahead and submit that. Make sure it stays submitted after it's accepted. Ooh, look at that, y'all. 0 milliseconds. 0 milliseconds beats 100% of users with Swift. Y'all know those are some good numbers. Those are the numbers I like to see, y'all. So with that being said, make sure you get one more look at the code. That's the top half of it. Read it, learn it, love it. Boom. Then this the bottom half. Read it, learn it, love it, internalize it, do what you have to do in order to make sure you learn from it so you can use this knowledge further down your LeetCode journey. And with all that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.